Okay, so now we move on to question A7, which is an R formula question. And in this question, you are supposed to show that cosine theta plus 2.5 sine theta is equals to 1.5. Now, where did this 1.5 come from? If you look carefully, 1.5 actually came from here. Okay, so you're supposed to express this so-called vertical height over here in terms of sine and cosine theta. That requires a bit of thinking here, and we will definitely need to cut the diagram into smaller parts. Okay, so if you look carefully, this is what I'm going to do. I hope you guys have tried this question as well. If you haven't, please go ahead and try. I'm giving you a hint. You need to introduce a horizontal cut first. Okay, so if you have not tried, go and try it. Go and introduce a horizontal cut to the diagram and try to figure your way out on how to show. So you may pause this video if you have not tried. Okay, so I'm going to start now. What I suggest is I'm going to cut it this way. All right, and then we're going to go about labeling all our angles that we know. Okay, but before that, take note that this entire shape here, as according to the question, is a rectangular table. That means to say this is 90, this is 90, this is 90, and this is 90. All right, and according to our dear alternate angle property, this will be theta as well. Now, if this is theta, that makes our dear friend here 90 minus theta. Oops. Okay, so what I need to find would actually be the sum of this height and the sum of this height over here. Okay, so we need to tackle part by part. Now, the first part that I'm looking at, all right, the first part I'm looking at is actually this triangle over here. So let me just draw this out, the small little triangle that we have over here. Now, of course, in your presentation, you can draw them into smaller parts to present your workings, which would definitely be clearer to the marker as well. This is theta, and this line height over here is actually, if you look closely to the diagram, is 2.5. Okay, and this is part of the small height which we need to find. All right, so from here, we would know that sine theta is equals to, I call this h over 2.5. Or rather, I call this h1. All right, h1 over 2.5. So h1 is equals to 2.5 sine theta. Now, at this juncture, if you look carefully, hey, I'm halfway through the question now. Now, how about this other half over here? Okay, let me just use a different color. I am looking at this orange triangle. So if I were to draw out, this is what I should have. Right angle, this is 90 minus theta. If this is 90, this is 90 minus theta. That means to say this is theta over here. Okay, and don't forget, this is the second height that we need to find here, h2. This is h1, and this is h2. Okay, so if you look carefully, according to the diagram, this is actually 1 meter. So if I can form a trigo equation, okay, it will be cosine theta equals to h2. Oops. h2 over 1. So therefore, h2 in this case is just cosine theta. So I know that 1.5 here is h1 plus h2, which in this case is just 2.5 sine theta plus cosine theta. Okay, you want to be anal a bit? We swap around the position, and that's how you show it. Yep, that's it for part 1. Okay, so this is how we attempt part 1. Now for part 2, it is pretty straightforward, I would say. Okay, so for part two, the question actually say find the angle theta. Okay, so it's basically asking you to go and solve this equation over here in order for us to find the angle theta. So how can we go about finding? Well, let's apply our formula. Okay, you can see that this is a 1 as a coefficient and this is 2.5, and therefore A is equals to 1, B is equals to 2.5. So if I do apply my R formula, R will be square root of A squared plus B squared, which is square root of 1 squared plus 2.5 squared. And that should give us square root of 7.25. And mind you, square root of 7.25 is actually not a square number, so I'll just leave this as it is for the moment. And of course, our alpha will be tangent inverse B over A, which is 2.5 over 1. And we should get... Okay, now if you notice, the question did not insist on whether you leave the answer in degree or radian. Okay, so I prefer to work with degree. I think degree is a unit that most of us are more familiar and comfortable with. Yeah. Okay, so to express this in our formula, I should get square root of 7.25 cosine theta. Now, because it's cosine and it's a plus in the original form, I should have a minus 68.198 equals to 1.5. Now, at this juncture, some of you may be asking, Mr. Chua, can I use sine instead of cosine for our formula? Sure, by all means, go ahead. But please take note, if you're to use sine instead of cosine, then the value of A and B would change, and that would essentially affect your value of alpha. Okay, because instead of 2.5 over 1, it will be 1 over 2.5. But at the end of the day, it should all lead us to the same answer. I leave it up to you guys to go and try on your own. So from here, it is just, solving of our normal trigo equation. This is equals to 1.5 over square root of 7.25. Okay, go on to find out what our basic angle is. It is 56.145. So theta minus 68.198. What are the values that I should consider? Okay, this is the first possible answer that I should have. But don't forget, because of ASTC, all right, and theta, which is, originally starts from 0, okay? Since I have theta minus 68.198, so actually my theta here, the limit, I can afford to go back by 68.198. So in other words, another possible answer I can have is negative 56.145. Then some of you might also be asking, okay, so can I consider the last quadrant, which is 360 minus 56.145? Yes, of course you can. You can even consider the next cycle, because the question, oops, sorry. Oh dear. Okay, sorry for that. Well, of course you can consider, one full cycle or even the next second cycle, so on and so forth. But there is no need to, okay, because in this case we are talking about dealing with theta in the context of a right angle triangle. So needless to say, our dear theta here should not exceed 180 degrees. Okay, should not exceed 180 degrees because we are talking about the context of a triangle. And if I want to be more precise, okay, we shouldn't even consider 180. In fact, it should be 90 degrees. Why? Because we are talking about the context of a right angle triangle. Okay, So in that case, it should be 90 minus 68.198. Okay, my range of theta value should be from negative 68.198. Okay, sorry, just let me write this clearly. All the way to 21.802. All right, so this is the range that I'm looking at. In other words, if you look at what we have over here, this is render useless. This over here is render useless as well. So actually, I should be considering this as my possible answer. So therefore, theta is just negative 56.145 plus 68.198. And that should lead us to 12.053. If my final answer in 1 dp is 12.1 degrees. And ladies and gentlemen, this is our answer. Sorry. This is our answer for theta. Thank you.